Hello everyone, I'm Amrita. In this video, I'm going to explain about flip-flops. Flip-flops is an important concept in FCD. Coming to the first slide, we have Introduction to Flip-flops. What is a flip-flop? A flip-flop is a digital electronic circuit used to store binary data. Flip-flops are the basic building blocks of memory units and sequential circuits in digital electronics. And in the next slide, we have basic function of a flip-flop. Flip-flops can store one bit of information, either 0 or 1. They flip between two states based on input signals. And they are used in registers, counters, and memory devices. And coming to the next slide, we have types of flip-flops. There are four types of flip-flops. They are SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. Coming to the SR flip-flop, this is the most common flip-flop among all. This simple flip-flop circuit has a set input S and a reset input R. The outputs are Q and Q dash, which is also called as inverted Q. And the operation of SR flip-flop is it can be set or reset based on inputs. And the characteristics are simple, but the S equals to R condition is undefined. The truth table of SR flip-flop is highlighted below. It is a diagram for S of SR flip-flop and it is the truth table. And coming to the JK flip-flop, the inputs are J, K and clock. The outputs are Q and inverter Q. And the operation of JK flip-flop is it combines features of SR flip-flop with additional functionality. And it toggles when both J and K are high. The truth table of JK flip-flop is highlighted below. It is the diagram for JK flip-flop and it is the truth table. And next we have D flip-flop. The inputs are data and clock. The outputs are Q and inverted Q. And the operation of D flip-flop is the Q output follows the D input on the triggering edge of the clock. And it simplifies logic by eliminating the possibility of undefined states. The truth table of JK flip-flop is highlighted below. It is a diagram of D flip-flop and it is a truth table. And at last we have T flip-flop. The inputs are toggle, which is T, and clock. The outputs are Q and inverted Q. The operation of T flip-flop is a simplified version of the JK flip-flop with just one input. As we can see, there is only one input which is toggle and the state toggles every time T equals to 1 and clock pulse is received. The truth table of JK flip-flop is highlighted below. As you can see, it is a JK flip-flop but with only one input. So it is a T flip-flop and it is the truth table of the T flip-flop. And next we have comparison of flip-flops. So now as we discussed all the flip-flops, let's compare them. For SR flip-flop, it is simple but has undefined state when both inputs are high. And for JK flip-flop, it is more versatile and it can toggle output. And for T flip-flop, it is simplified JK flip-flop and it toggles output on each clock pulse. And for D flip-flop, it is a simple data storage. It avoids undefined states. And next slide, we have applications. The applications of flip-flops are memory storage. The flip-flops are used in registers, shift registers and RAM. And in counters, flip-flops used to count binary numbers in digital circuits. And in clock dividers, flip-flops are often used in frequency dividers. And in sequencing, used in state machines and sequential circuits. And that's all about flip-flops. Thank you. Signing off, Amrita.